In this lesson, you'll learn to solve quadratic equations by graphing and estimate solutions of quadratic equations by graphing. How does a quadratic function model a freefall ride? As you speed to the top of a freefall ride, you are pressed against your seat so that you feel like you're being pushed downward. Then, as you freefall, you fall at the same rate as your seat. Without the force of your seat pressing on you, you feel weightless. The height above the ground in feet of an object in free fall can be determined by the quadratic function h of t equals negative 16t squared plus h sub 0, where t is the time in seconds and the initial height is h sub 0 feet. When a quadratic function is set equal to a value, the result is a quadratic equation. A quadratic equation can be written in the form ax squared plus bx plus c equals 0, where a does not equal 0. The solutions of a quadratic equation are called the roots of the equation. One method for finding the roots of a quadratic equation is to find the zeros of the related quadratic function. The zeros of the function are the x-intercepts of its graph. These are the solutions of the related equation because f of x equals 0 at those points. The zeros of the function graphed to the right are 1 and 3. In general, equations have roots, functions have zeros, and graphs of functions have x-intercepts. A good place to start to solve by graphing is to find the axis of symmetry. So we're going to plug into our x equals negative b over 2a again. So b is negative 3, and a is 1, because there's not a number in front of the x squared. The two negatives cancel out, so I've got 3 divided by 2. You guys have access to a really nice table feature on your calculator. Not that you couldn't make this table by hand, but we may as well use what we have. So to use this, we're going to hit Table, then we're going to type in x squared minus 3x minus 4, and then finally hit Enter. And I decided to fill in my start at negative 1, so you need to use the negative 1, and step by 0.5 because I wanted to get that 3/2 to show up, and then leave it on auto and hit enter, enter, enter until you've got OK. And after you've hit enter enough times to get this screen to show up, you can just use your down arrow to scroll through and we can fill in our values. I've got negative 1, 0, 0, negative 4. 1 gave me negative 6. 3/2 is going to be where our vertex is, so I definitely wanted to get that, was negative 6.25. 2 gives me negative 6 also. And as I continue to scroll down, I get 3 is negative 4 and 4 is 0. And hopefully you're seeing the symmetry here. We've got zeros and negative 4s and negative 6s all centered around the vertex. So if we pay attention to our table, our zeros are right there in the table, but we can plot points and see them visually there as well. And I'm going to be lazy and just show you their check step, but it'd be easy enough to do either in your head or on your calculator. If you substitute in negative 1 squared is 1, plus 3 is 4, minus 4 is 0. That works. 4 squared is 16, minus 12 is 4, minus 4 is 0. That one works as well. So we have shown numerically, graphically, and somewhat algebraically that the solutions of this equation are negative 1 and 4. A quadratic equation can have one real solution if the vertex is on the x-axis. Like example 1, it can have 2 real solutions, or it can have no real solutions if it's opening away from the x-axis and doesn't cross it. Technically, when a quadratic equation has one real solution, it really has 2 solutions that are the same number. Okay, the first thing we want to do on example 2 to solve by graphing is to put everything on one side of the equation. And then we'd like to know where the axis of symmetry is again. So I've got negative 4 over 2 times 1 again. So 4 divided by 2 is 2. And I'm not going to take the time to show you pictures of the calculator again, but we're going to type it in the table function. So you're going to hit table and they give you y equals. We're going to type in x squared minus 4x plus 4. And I picked 0, 1, 2, 3, 4 because I've got two values less than the vertex and two more, so it's nice and symmetrical. So when I substitute 0 in, of course, you don't need a calculator, so you're going to get 4 out. 1 gives us 1, 2 gives us 0, 3 gives us 1 again, 4 gives us 4 again. So once again, you can see the answer in the table or in the graph. And we should check again. 2 squared is 4 minus 2 times 4 is 8, and that does equal -4. And it's always a good idea to go back to your very original equation when you do a check step in case you made a mistake in your first step. Find two real numbers whose sum is 4 and whose product is 5, or show that no such number exists. So if we let x equal one of the numbers, then the other number would have to equal 4 minus x. Just real quickly, x plus 4 minus x equals 4. Since you know the product of the two numbers is 5, you know that x times 4 minus x is 5. So if we distribute that out, we'd have 4x minus x squared equals 5, or 0 equals x squared minus 4x plus 5. Finding our axis of symmetry, so we know where to send it around again. We got -4 again over 2 times 1 again. So x equals 2 is going to be our axis of symmetry. If we substitute 0 in for x, we get 5 for y. 1 gives us 2. 2 gives us 1. 3 also gives us 2. And 4 gives us 5 again. So we can see from the graph that our parabola opens away from the x-axis, so it is not possible for two numbers to have a sum of 4 and a product of 5. Often exact roots cannot be found by graphing. In this case, you can estimate solutions by stating the consecutive integers between which the roots are located. Solve by graphing again. If exact roots cannot be found, state the consecutive integers between which the roots are located. Once again, I want to know where my center is, so I'm finding the axis of symmetry. And over 2 times 1, so I've got 6 divided by 2 is 3. If we substitute 0 in for x, we get 3. 1 gives us -2, 2 -5, 3 -6, 4 -5, 5 is -2 again, and 6 is 3 again. When we plot the points, we can see it's not crossing at integers, it's crossing going from positive to negative and negative to positive. And so our roots happen when x is between 0 and 1 and when x is between 5 and 6. Now we could use GeoGebra or graphing calculator to find the exact values or pretty close to the real values, but at this point all they want to know is the between. The highest bridge in the United States is the Royal Gorge Bridge in Colorado. The deck of the bridge is 1,053 feet above the river below. Suppose a marble is dropped over the railing from a height of 3 feet above the bridge deck. How long will it take the marble to reach the surface of the water, assuming there is no air resistance? Use the formula h of t equals -16t squared plus h sub o, where t is the time in seconds and h sub ot is the initial height above the water in feet. They told us the original height is going to be 1,053 plus 3, so 1,056, and when it hits the water, the height will be 0. I'm not loving that -16, so I'm going to divide both sides by -16. I've got 0 equals t squared minus 66. I can then add 66 to both sides. And I've got 66 equals t squared. Take the square root of both sides. And square root of 66 isn't a very helpful answer, so I changed it to a decimal, and I got approximately 8.12 seconds. And it's also easy to type this into GeoGebra. When you type it in GeoGebra, they like y and x better. So I typed in y equals negative 16x squared plus 1056 and used the intersect feature to find the positive time because the negative time doesn't really make sense. We cannot travel back in time. Same thing when we take the square root of both sides. This would normally be plus or minus, but again, I don't know how to travel in time, so we're going to call it about positive 8.12 seconds, and they just rounded it to 8, so that's real approximate. The solutions or roots of a quadratic equation are the zeros of the related quadratic function. You can find the zeros of a quadratic function by finding the x-intercepts of its graph. A quadratic equation can have one real solution, two real solutions, or no real solution.